Welcome to COIS ADMN 1620, Introduction to Information Systems. This is Chapter 6, Telecommunications and Networking. Learning Objectives. Compare and contrast the major types of networks. Describe wireline communications media and transmission technologies. Describe the most common methods for accessing the Internet. Explain the impact that discovery network applications have had on business and everyday life. Explain the impact that communication network applications have had on business and everyday life. Explain the impact that collaboration network applications have had on business and everyday life. And explain the impact that educational network applications have had on business and everyday life. Chapter outline. 1. What is a computer network? 2. Network fundamentals. 3. The Internet and the World Wide Web. 4. Network applications discovery. 5. Network applications communication. 6. Network applications collaboration. And 7. Network applications education. Opening case. Myanmar suddenly goes online. What we'd like you to think about here is what you use as a source of news and its potential reliability, and how could software be used to verify the quality of news reports. What is a computer network? Bandwidth, broadband, file server, and router. Local area networks, or LANs. Metropolitan area networks, or MANs. Wide area networks, or WANs. Personal area networks, PANs. Enterprise networks with corporate backbone networks and software-defined networks, SDNs. A computer network is a system that connects computers and other devices, for example printers, through communications media so that data and information can be transmitted among them. Bandwidth refers to the transmission capacity of a network and is generally stated in bits per second. Bandwidth ranges from narrowband, which is relatively low transmission capacity, to broadband, which is relatively high network capacity. Local area networks connect two or more devices in a limited geographic area, usually in the same building, so that every device on the network can communicate with all the other devices. Many LANs will have a file server or a network server. That server would normally have software and data for the network. It would also house the LAN's network operating system, which manages the server and routes and manages communications on the network. Wide area networks, by contrast, cover a large geographic area. They typically connect multiple LANs. They're generally provided by common carriers such as a telephone company and international networks of global communication services providers. WANs are going to have large capacities, and they would typically have multiple channels such as fiber optic cables, microwave, satellite. They also contain routers, which are communication processors that route messages from a LAN to the Internet across several connected LANs or across a WAN such as the Internet. The Internet is an example of a wide area network. The various types of computer networks, ranging from small to worldwide, starting at the small end, are personal area networks, then local area networks, then metropolitan area networks, then wide area networks. PANs are short-range networks, generally just a couple meters. They're used for communication among devices close to one person. They can be either wired or wireless, and we're going to talk about them later in Chapter 8. Figure 6.1, Ethernet local area. So this is a local area network built by Ethernet cable, still the most common in an office space. Of course, there's generally going to be some sort of wireless connectivity in the network. However, that's probably a less secure alternative for many businesses than having an Ethernet local area network. So this just shows a group of computers, a server, and a printer all connected to the same local area network. Figure 6.2, enterprise network. So an enterprise can be made up of a group of LANs built on a wide area network. The LANs can be divided by floors or departments or functions. It depends on how the company chooses to set up their network. In this instance, there is a mainframe even that's less and less common, of course, that's connected to the wide area network. That would still happen in banks probably, and insurance companies, businesses that are doing massive amounts of financial transactions or massive amounts of processing. Network fundamentals. We're going to talk about basic concepts, communications, media and channels, network protocols, and types of network processing. Basic concepts: digital signals and analog signals, a modem, modulator, demodulator. There are dial-up modems, cable modems, and DSL modems. Digital signals are ones and zeros exclusively. Analog signals, instead of being pulses that represent ones or zeros, are going to be continuous waves that transmit information by altering the amplitude and frequency of the waves. The original modems that we used to connect to the internet at incredibly low speeds were used to convert the signals from analog to digital and vice versa. So the computer can't do anything with an analog signal, so you need a modem to convert the analog signal into ones and zeros, and then vice versa when you're sending data back through the telephone line. Dial-up modems, which is what I'm referring to, are almost extinct nowadays, but were very common in the beginning for connecting to the internet. Cable modems are modems that operate over coaxial cable, a good example of which is cable TV. They do offer broadband access for corporate intranets or for individuals. They vary widely in speed because of the bandwidth offering from the providers, which is usually between 1 and 6 million bits per second, which is megabits per second, for downloads, and between 128 and 768,000 bits per second, which is kilobits per second, for uploads. Cable modem services share bandwidth among subscribers in a locality. So the same cable line connects many households and you get a share of that. If there's a large number of neighbors that are using the internet at the same time, cable speeds will decrease significantly. DSL modems operate on the same lines as voice telephones and dial-up modems. DSL modems always maintain a connection, so an internet connection is immediately available. Communications, media, and channels. We're going to look at twisted pair wire, coaxial cable, and fiber optic cable. Figure 6.3, twisted pair wire. This shows the 4 twisted pairs in the wire that are woven into connections that you would normally see that look like large telephone jack connections. Figure 6.4, 2 views of a coaxial cable. You would most normally have seen this in cable TV, going into the back of a TV or into a modem if you have a cable modem. Figure 6.5, 2 views of fiber optic cable. This is what fiber optic cable looks like if you happen to be fortunate enough to have fiber optic internet. Table 6.1, advantages and disadvantages of wireline communications channels. Starting with twisted pair wire, the advantages are it's inexpensive, widely available, and easy to work with. The disadvantages are that it's slow, i.e. low bandwidth. It's subject to interference. It's easily tapped, so that it's low security. Coaxial cable, the advantages are higher bandwidth than twisted pair, less susceptible to electromagnetic interference, and the disadvantages are it's relatively expensive and inflexible, it's easily tapped, so low to medium security, and it's somewhat difficult to work with. Fiber optic cable, the advantages are very high bandwidth, relatively inexpensive, and it's difficult to tap, meaning it's got good security. The disadvantage is it's difficult to work with, it's very difficult to splice. If it's broken, it's hard to repair. Network protocols. Ethernet and TCP/IP, which is Transmission Control Protocol / Internet Protocol. We're going to talk about packet switching and the 4 layers as described in the figure 6.6 upcoming. Ethernet is a common LAN protocol. Many organizations use 100 gigabit Ethernet. That's the speed through which the network transmits data. The 400 gigabit Ethernet is the latest standard for high-speed network communications. Many smaller organizations would have 1 gigabit Ethernet. TCP/IP is the protocol of the internet. TCP/IP uses a suite of protocols, the primary ones being the ones that are named: Transmission Control Protocol and Internet Protocol. TCP performs 3 basic functions. It manages the movement of data packets between computers by establishing a connection between them. It sequences the transfer of packets, and it acknowledges the packets have been transmitted. IP, or Internet Protocol, is responsible for disassembling, delivering, and reassembling the data during transmission. 4 layers of the TCP/IP reference model / protocols: the application layer, the transport layer, the internet layer, and the network interface layer. Figure 6.6, showing the 4 layers of the TCP/IP reference model. If we take an email, sending a message through the SMTP protocol, which is the Simple Mail Transfer Protocol, that's on the application layer, and what we accomplish is we send an email, the message is received. We break the message into packets and determine order on the transport layer. The packets are reordered and replaced if lost. We assign sending and receiving IP addresses and apply these to each packet on the internet layer. That allows the packets to be routed through the internal network to the desired IP address. We determine paths across the network / internet to the intended destination on the network interface layer, and that governs the receipt of packets. Figure 6.7, packet switching. There's a message that's being transmitted from Toronto to Calgary. The message consists of 6 packets. Those 6 packets go various routes between the 2 destinations. For instance, packet 1 goes from Toronto to Regina, then Regina to Calgary, whereas packet 4 also goes from Toronto to Regina, but then goes from Regina to Winnipeg and Winnipeg to Calgary. The point being is that the packets travel a different route and need to be reassembled in the correct order when they arrive at the destination. Types of network processing. Distributed processing includes client-server computing, fat or thin, peer-to-peer processing, P2P approaches, which have the components of accessing unused CPU power among network computers, and real-time person-to-person collaboration, and advanced search and file sharing. Client-server computing is when you have 2 or more computers in an arrangement where you've got some machines called servers and other machines called clients, which are just regular PCs, and the organization will generally perform the bulk of processing on the servers because they're the more powerful machines. Client-server computing has the idea of fat clients and thin clients. This is reviewed in Technology Guide 1. Fat clients have large storage and processing power and can run local programs if the network goes down. In contrast, thin clients have no local storage and only limited processing power. Peer-to-peer processing is the idea that all the nodes, all the computers that are on the network are equal. They share in their resources. Peer-to-peer processing is used in things like Bitcoin and file sharing applications. The Internet and the World Wide Web. Some terms that we're going to deal with are Internet backbone, intranet, and extranet. We're going to talk about accessing the Internet, the future of the Internet, and the World Wide Web. Figure 6.8, Canada's Internet backbone. Internet service providers connect to one another through network access points. NAPs are exchange points for Internet traffic that determine how traffic is routed. NAPs are key components of the Internet backbone. This figure shows a schematic of the Internet in Canada. The red lines that link the main Canadian cities represent the ultra-high-speed network and constitute the Canadian Internet backbone. If you look in the north, you can see satellite dishes. These small satellites provide connectivity to the Internet backbone for the remote locations in Canada where a fiber optic link is still not available. Accessing the Internet. Connecting through an online service, connecting through satellite, connecting through other means such as internet kiosks, smartphones, or Google Fiber. And then we're going to also talk about addresses on the internet. Table 6.2, internet connection methods. Dial-up, that is connection through a conventional telephone line. That's the way things started off, and there are probably places in Canada where that is the best that they can do still. DSL is broadband access through telephone companies. Cable modem, as we've talked about before, is access over cable TV coax cable. Satellite is access over radio wave satellite network. I had a satellite dish when I first moved to the area around 20 years ago. I was out in the country and I had a direct ground to satellite connection. It was, of course, not very fast and had limited bandwidth available on a daily basis, and it was expensive. Wireless is access via wireless access point or cell phone network. There's a lot of wireless connectivity out in the country still where you're going point to point from a tower to your house. And then there's the other way that people think of wireless, which is when you're sitting in Starbucks using Wi-Fi. Fiber to the home is broadband access via a fiber optic cable. Again, when I lived in the country, they did put fiber optic cable down the road, which was due to some sort of government subsidy program, and they never connected it. They never turned the service on in the 5 or 6 years that I waited for that to happen. It's About Business 6.1. Is broadband internet a right or a privilege? What we want you to consider here is how broadband access facilitated separation strategies implemented in response to the COVID-19 pandemic, and the different methods that you can use to access the internet. Addresses on the internet. Internet Protocol IP addresses for domain names. The ICANN, the Internet Corporation for Assigned Names. Top-level domain, tld.com, .edu, .mil, .gov, .org, and .ca. IP addresses are sets of numbers in 4 parts, separated by dots. The number goes from 0 to 255 in each of the 4 groups of numbers. So an IP address could be 135.112.22.0. That is using the first IP scheme, which is IP version 4. That gives about 4.3 billion addresses, which is simply not enough nowadays because we have so many devices connected, and devices will have unique IP addresses. So we've gone to an IP version 6, which is 128 bits, which is a incredibly huge number, 2 to the exponent 128. So we're not likely to run out of addresses anytime soon using that. Domain names have several parts to them. The rightmost part, the .ca, .com, .edu, is the top-level domain. We use domain names because we simply can't remember numbers that effectively as humans. Imagine having to remember the number that Google is as an IP address or one of their many IP addresses. There are country code top-level domains such as .it for Italy, .ca for Canada, .de for Germany. There's internationalized country code top-level domains. Those are country code top-level domains that aren't in Latin character sets. Perhaps they're in Arabic or Chinese. There's generic top-level domains, .gov, .edu, .com, .mil, .org, .net. They've also introduced .aero, .biz, .coop, .info, .museum, and so forth. ICANN is the ultimate authority that accredits certain companies called registrars to register the domain names. In Canada, the Canadian Internet Registration Authority, or CIRA, manages the registration of .ca domain names. The future of the internet. 3 factors could cause internet speed reductions. The increasing number of people who work online, resulting in growing usage needs. Viewing of full motion video files on popular websites such as YouTube, requiring large amounts of bandwidth. And increasing demand due to healthcare technologies sending high-definition files, for example, X-ray images. Canary and Internet 2 are Canadian and US, respectively, research and development corporations looking to develop communication technology resulting in higher bandwidth connectivity. It's about Business 6.2, the Splinternet. What we'd like you to consider is, where are you and your family members or friends located? Do you and they have open access to the internet? And is tiered internet access available in your neighborhood? Do you have to pay more for faster access? The World Wide Web, WWW. A system of universally accepted standards for storing, retrieving, formatting, and displaying information via a client-server architecture. Enabling use of the WWW requires hypertext and hyperlinks, website, webmaster, uniform resource locator, URL, and browsers. Hypertext is the underlying concept defining the structure of the World Wide Web. Hypertext is the text displayed on a computer display or other electronic device with references, called hyperlinks, to other text that the reader can immediately access, or where text can be revealed progressively at additional levels of detail. A hyperlink is a connection from a hypertext file or document to another location or file, typically activated by clicking on a highlighted word or image on the screen or by touching the screen. To access a website, the user must specify a URL or Uniform Resource Locator, which points to the address of the specific resource on the web. For instance, the text uses the example of Microsoft, which is http://www.microsoft.com. The HTTP stands for the Hypertext Transport Protocol. The remaining letters in the URL, the www.microsoft.com, indicate the domain name that identifies the web server that stores the website. Browsers provide a graphical front end and enable users to point and click their way through the web, which we call surfing. Network applications, discovery, search engines and meta search engines, portals, publication of material in foreign languages. We are all familiar with search engines. They are computer programs that search for specific information by keywords and report results back to us. They're created through the use of web crawlers, which are computer programs that browse the web and create a copy of all visited pages. Then the search engine indexes those so that we can search using that index. A meta search engine is a search engine that searches multiple other search engines at once. It is estimated that 80% of online content is available in only 1 of 10 languages: English, Chinese, Spanish, Japanese, Arabic, Portuguese, German, French, Russian, and Korean. 3 billion people speak one of these as their first language, but more than 50% of all online content is written in English, and it's only understood by 21% of the world's population. Companies invest resources to make their websites accessible in multiple languages, and there are online translators such as Google Translate that are available to perform translation services. Portals. There are commercial portals, affinity portals, corporate portals, also known as enterprise portals, and industry-wide portals. A portal is a web-based personalized gateway to information and knowledge that provides relevant information from different IT systems and the internet using advanced search and indexing techniques. A commercial portal is the most popular type of portal on the internet. It's intended for a broad and diverse audience. It offers routine content, some of which is in real time. An example is Yahoo Canada. An affinity portal is a single point of entry to an entire community of affiliated interests, such as a hobby group or a political party. A corporate portal is a personalized single point of access through a web browser to critical business information located inside and outside of an organization. Corporate portals are associated with a single company, but an industry-wide portal serves entire industries. An example that the text uses is the Canadian Trucking Alliance, which is a portal for the trucking industry and the trucking community, including professional drivers, owner-operators, and trucking companies. Figure 6.9, York University Alumni Affinity Portal. This is clearly a portal that is designed to be used by York University alumni and their friends. Figure 6.10, Google Translate. We talked about this briefly before. This allows us to copy and paste a foreign language content, detect which language it is potentially, and translate it into another language. It's useful, but it's far from perfect. I've had many students try and use Google Translate or something similar to write an essay in their own native language, in their first language, to translate it into English, and it is not at the point where it does that effectively. Network applications, communication. Some of the applications are electronic mail or email, web-based call centers, electronic chat rooms, voice communication such as internet telephony, which is VoIP, unified communications, UC, and the use of telecommuting. Telecommuting is a process by which highly prized workers are able to work anywhere, anytime. To update that, during the COVID pandemic, it was many workers were allowed to telecommute as people weren't able to gather in offices. This is done by knowledge workers most effectively. It allows a distributed workforce, and there are advantages and disadvantages of doing so. Some of the advantages are allegedly reduced stress and improved family life. It offers employment opportunities for people that are housebound. Maybe they are single parents or they are disabled persons. The benefits for the employers include increased productivity, I'll put an asterisk beside that, the ability to retain skilled employees, and the ability to attract employees who do not live within commuting distance. There are potential disadvantages for employees. The major disadvantages are increased feelings of isolation, possible loss of fringe benefits, lower pay in some cases, no workplace visibility, lack of socialization, and potentially slower promotions. Employees also often have difficulties in managing both the demands from work and family. The major disadvantage for employers are difficulties in supervising work and potential data security problems. I will offer the Elon Musk perspective of people working remotely, where he has told the people that work for him at Tesla that they will be in the office if they're at the senior management level or above. And if they don't like that, they can go somewhere else and they can pretend to work there. It's About Business 6.3, Telecommuting. We'd like you to consider, how have information systems and internet applications facilitated telecommuting? What are some career choices that you are considering? Would they be suitable for telecommuting? Network applications, collaboration. We're going to talk about crowdsourcing and teleconferencing and video conferencing. Collaboration. Working together to accomplish certain tasks is performed using technologies and processes such as work groups, workflow, virtual teams or groups with virtual meetings, virtual collaboration, crowdsourcing, electronic teleconferencing and video conferencing, and synchronous versus asynchronous methods. Work groups are two or more individuals that act together to perform a task. Workflow is the movement of information as it progresses through the sequence of steps that make up the organization's work procedures. Virtual groups or teams are composed of individuals who are working at different locations who meet electronically. Virtual collaboration, or sometimes called e-collaboration, is the use of digital technologies that enabled organizations or individuals who are geographically dispersed to work together collaboratively. Synchronous means that the group is collaborating in real time, for instance, through a video conference or some sort of virtual meeting like Zoom, or using an instant messenger type communication, whereas asynchronous collaboration means that they're using something like email to communicate ideas, where the sender and receiver are not communicating at the same time. It's About Business 6.4, the Boeing Collaboration Center. What we'd like you to consider here is, how could Boeing's technology be adapted to remote meetings? If you were buying an airplane or helicopter, how does the Collaboration Center illustrate Boeing's technology capabilities? Crowdsourcing benefits. Crowdsourcing is a type of collaboration where an organization outsources a task to an undefined, generally large group of people in the form of an open call. It provides many potential benefits to organizations, especially when you're looking at exploring problems, potentially resolving them at a relatively low cost and quickly. The organization can tap a wider range of talent than might be present amongst its own staff. By listening to the crowd, organizations gain firsthand insight into their customers' desires. Crowdsourcing taps into the global world of ideas, helping companies work through a rapid design process. Crowdsourcing concerns. It's unclear how to define the crowd. For example, do we just pull experts? It's difficult to maintain accuracy of the content created. There's uncertainty about the relevance of the content. There's a high volume of ideas, prohibitively expensive to evaluate. The content provided may violate copyrights. The quality of content may be variable based on the unknown composition of the crowd. Figure 6.11, telepresence system. Telepresence is the latest form of video conferencing, which allows seamless sharing of data as well as being able to see and hear the people that you're talking to. Network applications, education. We've got e-learning, which, as everyone should be aware, is learning supported by the web. Distance learning, any learning situation in which teachers and students do not meet face-to-face. And virtual universities, which are online universities in which students take classes via the internet at home or an off-site location. Closing case. The network neutrality battles continue. We want you to think about how you use the internet and which services could be slowed by internet service providers. For example, video streaming, video gaming. Would you use your ISP's streaming site if it resulted in your having access to a higher data cap? Why or why not? That brings us to the close of this chapter's lecture. Thank you for your attention.